Good morning, students. I am Manikant Mishra, Modern English School, New Area. So yesterday we have started to discuss about covalent bond, and we have also discussed the covalent bond formation in homoatomic molecules and heteroatomic molecules. So just once again, just to recap it, like H2. So each hydrogen has one electron. The sharing takes place between the same two atoms. The condition is the shared pair electron will be at equidistant from the nucleus. In a covalent bond formation, when the covalent bond formation takes place between the same two atoms, then the shared pair electron will be at equidistance from both the nucleus. This is a shared pair. Shared pair of electron. Now, the shared pair of electron is at equidistance from this hydrogen as well as from this hydrogen. In the covalent bond formation, one of the condition that the shared pair electron will be at equidistance from both the atoms. So, in a hydrogen molecule, the shared pair electron is at equidistance from both the hydrogen atom. As a result, electron density remains equal over both the hydrogen. But if you talk about the heteroatomic molecule HCl, here H has one electron and Cl has 7 electron in its outermost shell. Now the sharing takes place between hydrogen and chlorine of one pair of electron. As a result, this shared pair electron supposed to be at equidistant, but it shifts towards the chlorine. This can also be represented by arrow. Now, if you observe, you see the arrow head is not coinciding at the center, rather it is towards the chlorine. This arrow head is towards the chlorine, little away from the hydrogen but towards the chlorine. This arrow head represents the localization or position or locality of shared pair electron. This arrowhead represents the position or locality of shared pair electrons. So the shared pair electron is shifting towards the chlorine atom. It means away from the hydrogen atom and closer to the chlorine atom. So as a result, what happens? The electron density over the hydrogen becomes less, and over the chlorine atom becomes more. Now why it happens? It is because the chlorine has more tendency or more love for electron. This this activity, this tendency of a element due to which attracts the electron towards itself is called electronegativity. What is electronegativity? The tendency of an element to attract the electron towards itself. Chlorine has more electronegativity as compared to hydrogen. Its electronegativity value of hydrogen is 2.1 and chlorine has 3. Electronegativity value of chlorine is 3, whereas electronegativity value of hydrogen is 2.1. So because of this difference in the electronegativity value, the chlorine attracts the shared pair electron towards itself. As a result, the electron density over the hydrogen becomes less and electron density over the chlorine atom becomes more. So this creates a charge. This creates a pole. This situation, the shifting of electron towards one of the nucleus of an atom creates polarity. As a result, it becomes a delta positive charge and it becomes delta negative charge. I mean to say here that the charge developed over the hydrogen and charge developed over the chlorine is a very small charge. We represent that small charge as delta positive and delta negative. Is not equal to like electron has a charge of 1.602 into 10 to the power minus 19 coulomb. Is not that much charge, lesser than that. That's why we call it also here partial positive charge, partial negative charge. Due to shifting of electron from the shared pair towards one of the atom which has more electronegativity value. So now covalent compound or covalent molecule in which two different atoms are bonded together by covalent bond, in which one of the atom has more electronegative value, due to which a shared pair electron is shifted towards one of the atom. As a result, the bond thus formed is called polar covalent bond and the molecule is called polar covalent molecule. So this bond is called polar covalent bond. Polar covalent bond, or the HCl as a result called polar covalent molecule. Similarly, if you talk about the H2O, here also hydrogen, oxygen, hydrogen. Electron in its outermost shell, and each hydrogen has one electron. Once again, here oxygen has a greater electronegativity value. Like oxygen has also electronegativity value 3. Electronegativity value of oxygen is 3 and hydrogen we have discussed 2.1. So here what happens, the oxygen also acquires partial negative charge and hydrogen acquire partial positive charge due to shifting of shared pair electron towards the oxygen. So once again, the bond thus formed is called polar covalent bond and the molecule is called polar covalent molecule. So H2O is a polar covalent molecule. HCl is a polar covalent molecule. Similarly, HF, HBr, all these are the example of a polar covalent molecule where there is a difference of electronegativity is little more than the shared pair electron is shifted towards one of the atom which have higher electronegativity value and the bond thus formed is called polar covalent bond and the molecule is called polar covalent molecule. Just now you see that when the two same atoms are connected by covalent bond, then shared pair electron is at equidistance from both the nucleus. As a result, the bond so formed is called non-polar covalent bond. So in a H2, O2, N2, in all these, the shared pair electron is at equidistance from both the nuclei. So the bond thus formed is called non-polar covalent bond. But when we talk about the heteroatomic molecules, when the two different atoms are connected by covalent bond and one of the atoms have more electronegativity value, then the bond thus formed is called polar covalent bond and the molecule is called polar covalent molecule. Hopefully that you will understand if you watch the video carefully. Thank you. Have a nice day.